Alright guys, Throttle Performance here. Let's do something a little different. Just kind of stuff I like to do. Probably not going to help most of you, but give it a shot anyways. Maybe if you're a nerd like me, you might find this interesting. So we're looking at a schematic for an AOD transmission. You know, I know a lot of builders that don't want to do these anymore. The valve body is kind of a dreaded piece, and I don't like them either. I do a lot of them, but the valve body is kind of a pain to work on, and as the stuff gets older and starts getting corrosion in it and things like that, it's just a little bit tricky to work on these. They can be very time consuming, so but anyways, I'm not going to really show you how to work on it. I want to just try to show you a little bit about how it works, maybe take a little bit of the mystery out of it. Maybe one of you guys are wanting to design your own valve body kit for it or something. Learn how to modify it and have some fun with it. Maybe you have nothing better to do with your life and you don't want to just do the easy way and just go buy a shift kit or something. You know, that would be the smart thing to do. But alright, if you don't want to do any of that and you want to try to learn something from this thing, so let's take a look at it. I'm just going to kind of quickly go over each valve. This could be something I could spend a week on, but you know, in full disclosure, I mean, I know a lot about the valve body and I tweak things in it, but I'm not going to call myself a, you know, major expert on it or anything. I'm a Voc school dummy. I'm not an engineer. I was never formally trained as an engineer or anything like that, but I've spent a lot of time with these things and it's just what I do for work, so I have to try to understand it to some extent. And, you know, if you're a regular transmission shop where you work on everything and anything, well, you certainly can't learn every transmission like this. You just have to learn how to take it apart, put it back together, maybe rely on a packaged kit if you want to do that to it. And we'll talk about, you know, if this thing really should be shift kitted or needs to be. You know, that's an interesting question on a lot of these valve bodies too. The factory goes through a lot of trouble to make them work a certain way, and then we, you know, trust the aftermarket to say, oh yeah, the factory screwed it up, and you're going to need our valve body kit to fix everything that they screwed up on. Well, did they? I don't know. You know, that's debatable. Just a matter of opinion and also a matter of what the objective is. I'm in the high performance world, so most of my customers want something different than what the factory chose to give them. So, alright, I don't want to make this video too long. This is probably going to be like watching paint dry, but alright, so you have your main oil pressure regulator valve. And as it says, it controls the pressure in the valve body. Everybody kind of knows about pressure. A lot of people have checked pressure and things like that. So this is what controls that pressure. Now there's also what they call this boost valve on it. So this will help the oil pressure regulator vary. So typically what happens here is with throttle, so say as you push the accelerator pedal closer to the floor, line pressure goes up because the output of the engine increases as you give it more throttle. So the system will require more pressure to hold the clutches so they don't slip and that sort of thing. And, you know, generally on a unit, you know, there's a lot of things in here, and I'll quickly go over some of them, that cushion the shifts so the shifts aren't super hard. And, you know, I used to think, and most of you probably think, those really hard shifts are necessary so that the clutches don't slip and all that. Well, to a point. You know, when you get into these overdrive units, they don't like a real super hard shift because they're more delicate than some of the older units, and you can break shafts and rip spines out and one-way clutches and things like that. So super hard shifts are not necessarily all that desirable. And I've kind of backed off on some of that. You know, like I used to sell a stage 3 valve body. And if you'll notice on my site, it's stage 1 and 2. No more stage 3. Just not necessary. And honestly, there's really no advantage to it. Some guys still want it. Some guys just like that feel. I used to when I was young. I don't know, I'm not as impressed by that anymore because I think back then it was more, you know, you put your own valve body kit in by yourself and, you know, you just felt and noticed that difference. It was just kind of an instant gratification thing. And you felt like, yeah, I did something. I made a difference to this unit. And you did, but now I kind of appreciate what the factory was trying to do by smoothing the shifts. And when you can have a shift that's fairly smooth and still accomplish the goal, and the goal is always to make it last, that's kind of more impressive. You know, that's something that just takes a lot more time and research and, you know, so that's a whole other thing. But, all right, I'm going on too long here. I want to quickly kind of go through this. So this boost valve has 3 different lands on it, okay? One land is, let me see, yeah, it's this one here. Yeah, it's labeled. The middle land here is reverse boost. So because of the geometry and the extra forces that are required to reverse the gear train, you know, for this just, you know, backing the car up, it requires a boost in pressure. So when you're in reverse gear, oil will come to this area and oppose this main pressure regulator, and in a sense it's just raising the pressure temporarily while you're in reverse. So normally there's not oil there except only in reverse. Now here is your TV, and TV stands for throttle valve, and that is basically the transmission is being responsive to where the throttle position is, meaning the gas pedal. So as you step on the gas, TV pressure increases pressure on this land, more opposition to the main regulator, and that's increasing line pressure for the clutches to hold. And also what this accomplishes is, which is pretty cool, when you're just driving with easy throttle, you know, light throttle, just easy driving it around, the shifts are a little softer because you have less pressure. But when you lay in the throttle more, the line pressure increases and the shifts get more firm as required. So that's a pretty cool feature, and there's a lot of workings to make that happen. Now, you'll see this line pressure. Red is always full line pressure in these circuits. And TV is going to be yellow, and there's other things as well. But so right now we're just looking at the red and yellow. No yellow on this one, obviously. I'll show you another diagram. But so this here, this basically gives this a little pressure boost. And if you notice here, it's running through the 2-3 shift valve. So in first and second gear, you get this pressure boost. When you shift to third gear, and this valve will stroke and stay down on third and fourth gear, this line pressure will go away. And what will happen is your line pressure, overall main line pressure, will be reduced. And again, this happens once you shift into third gear. And a popular modification for these is to keep that pressure on all the time. And the reason is because we're trying to make third gear last and the overdrive band last better for a performance application. Downside of doing that, though, is 2-3 shift feel and 3-4 shift feel get more firm because we have more pressure than what the circuits were originally designed to have. So that's something, in the performance world, that's very desirable, to have that increased clutch capacity for third and fourth gears. If it's a stock car driving around, somebody might not like that because it'll make the shifts more firm. So that's something there. And I'm not going to, please, for the love of God, don't start sending me a bunch of emails asking me how to do this or that. I'm going to try to give you some knowledge here, but I'm not going to sit down and teach you every little thing that you need to do or want to do. That's why I sell valve bodies. You know, this stuff's done for you. But so if you want to find a way to keep this pressure on, there's various ways of doing that. And a lot of your, not a lot of them, but some of the shift kits on the market do it. Some don't. Some have other ways to approach this problem. Again, depending on the application, it's not always the best thing to do. Alright, so that's the main pressure regulator. Give me a minute. I want to flip to a different diagram here. Alright. So another thing maybe you could do. So you have two valves in this pocket. This is your low servo modulator valve. And what that does is in manual first only, the reverse band is applied, and that provides engine braking. So because you have a one-way clutch holding in conjunction with it, the only time this band really does anything is for the engine braking effect when you basically say you're coasting down a hill or let off the throttle or something, and it just kind of it'll slow the vehicle down. So what this valve does is, you see this kind of checkered pattern here. That's a modulated pressure, and that will basically be less than line pressure. So this valve will basically, the reason they do this is for when you downshift in a first, it will hopefully not lock the tires up. It just kind of cushions that shift into manual low if you're rolling. So they modulate that pressure. So this valve here, say maybe if you were building something for a rock crawler or something, and you were doing a lot of manual low first gear, going down hills and things like that, and you find that you're tearing up the reverse band a lot. Typically in this unit, reverse band is never a problem, so it's usually adequate the way it is. But in a special application like a rock crawler, maybe you would want to either eliminate this circuit and have full pressure on the band, or modify it so that the pressure is a little bit higher than what it is. I don't know what it is offhand. I think it's around roughly 40 pounds, but I'm not sure on this unit. I don't remember. I have checked that before. But anyways, maybe if it's a heavy-duty rock hauling application, maybe 60 pounds would be better if it's 40, maybe 80 pounds, whatever. Something you gotta experiment with. So, okay, and the next valve in the pocket is the 2-1 servo valve, or scheduling valve, I'm sorry. And what that'll do is it's kind of a safety. So if you're in manual low, it'll try to help you not over rev the engine. And you know, for somebody that just accidentally puts the shifter back into first, either while you're rolling or you're just starting out in manual first, it will eventually shift itself automatically back into second, even though it's a manual low position. It's a safety, if you will. And also, if you were cruising down the road and you take the shifter and you slam it into first, that could be very bad. It would probably lock up the tires if it were to go into first gear and apply that reverse servo. So another reason this valve is here is so that you can't do that past a certain speed, and it would shift into second and not first. And this is spring actuated, so if you wanted to change that point, you could mess with that spring tension. You could potentially block that valve from moving altogether if you didn't ever want it to, you know, if you want to be able to run down the road 100 miles an hour and slam it into first gear and kill yourself or something. You for some reason had that crazy desire. You would have to modify that valve in order to do that. And that, again, sometimes there's a purpose for that other than being stupid. You know, if it's something you're manually shifting and you want to be able to wind out first gear longer to a higher RPM, that would be a reason to do that. Not the other reason I mentioned. Please don't do that. Alright, so 3/4 backout valve. Yeah, this is going to be a super long video. I'm going to hurry up here. Sorry, guys. 3/4 backout valve. So this is essentially a valve. It's a cushioning effect. Okay, so if say your foot's in the throttle pretty heavy, and the transmission is about to make a 3/4 upshift, and you all of a sudden back off on the throttle during that time, the transmission would just make a horrible, like, clunk, kind of jerky shift if you were to do that right at that 3/4 shift point. And what that valve does is it just tries to calm that down. So if you backed out in the throttle, it would kind of go into a mode where it just tries to make the shift smoother. That's the best way I can explain that. Not typically any big advantage to making changes to that, in my opinion. 2-3 shift valve does exactly what it says. It shifts you from second to third gear. Now, you have this 2-3 TV modulator valve. So what's happening here? Let me give me 1 second. I'm going to flip to another page. Okay. So this is all your TV pressure. What this is, it's a pressure regulator, okay? So it's a pressure regulator within the regulated circuit, which is really confusing. And this TV pressure opposes, your governor pressure is on this side of the valve trying to stroke it, but this TV pressure opposes that. You have a spring in here that does that as well, and then you have a spring on this TV limit valve. So let's say, for example, so here's a complaint with this unit. When it has the lockup converter in it, and you're coming down, you know, your foot's off the throttle, and you're pressing the brake, say you're in fourth gear, the unit starts to downshift. So it downshifts into third, and then what the complaint can be is the way the lockup is designed in this transmission, what can happen is if this 2-3 shift valve doesn't return to its rest position fast enough, it can almost want to stall the engine And sometimes you can feel the car kind of bucking as you come to a stop. And a lot of guys know this about the AOD. They don't know what it is. And then maybe, you know, just before you come to a stop and just before it actually kills the engine, it'll all of a sudden release, and then the car, you know, it'll stop bucking and come back to normal. Or maybe it won't. So usually you can fix that by just setting the TV pressure properly. Usually just adding a little more TV pressure to it. And basically what you're doing is, as the governor pressure is reducing, you want a little more TV on it to push this back up. And it's also, you know, some people complain that the 1, 2, and 2, 3 shift points are too close to each other. You know, so one thing you can do, there's a spring that actuates on the 2, 3 shift valve itself, which you could maybe experiment with a custom spring, either, you know, tighter or looser, depending on what you're trying to do. The other thing you can do is play with this pressure regulator on the TV. And this is all assuming that you can't get what you want just by adjusting TV pressure. Most of the time you can. And this is not necessary. So this valve here, this is a pressure regulator again. So changing this spring, you know, will change this pressure, this TV pressure opposing this valve. So that's just another place you can experiment with. We could have a whole video on just doing that. I'm not going to get into all that today. If there's interest in going into further depth on this, you put it in the comments. Don't email me about it. Just put it in the comments. I do go through those when I can. I respond to them when I can. I am pretty busy, so you got to be patient with me. This is your TV pressure, and this throttle plunger is essentially what's being pushed in when you press on the throttle. And all these valves are just on all how this works. This is the main line pressure coming into it. And then this all here is the regulated pressure that goes out of it. And there's also a kickdown feature in there. So what that does is, when you push this plunger in far enough, there'll be straight line pressure that will go through this circuit and come up here. And what this will do is it'll dump straight line pressure. I'm sorry, it will continue on here, but it's hard looking through the camera and doing this. So this oil will come down here. You have your 3/4 shift valve, and this is essentially the same as a 2/3. You have this same pressure regulator type of setup with the spring on it, and then you also have an outer spring that controls just the valve itself. Two things you can experiment with. But when you go to that kickdown mode, this TV oil will turn red, meaning it'll turn a line pressure, and it will push this, most of the time, push this shift valve back up and shift you from 4 to 3. Also, the other thing it does is it will not allow the transmission to go in 4th gear at wide open throttle because we've put line pressure below it. Another thing you could do, if you were designing your own shift kit or something, if you want it to shift into 4th gear at wide open throttle, you could potentially stop this oil. You would block this passage so that this can never send line oil up to that. That would be a reason maybe you would want to do that. All right, let's continue on here. Here's an interesting valve. This 2/3 backout valve. So what it does is you have multiple holes in your separator plate, and they're orifices, and it's kind of showing you them here. So for direct clutch application and forward clutch application, you have different sets of holes. So depending on throttle valve, this backout valve will dictate where the oil goes through these holes. So at a higher TV pressure, it will push this valve and send you through the other set of holes that are larger. Okay, so this is kind of a cool thing because as you give the engine more throttle, this will change calibration of the transmission. Depending, and this is something you can play with. There's a spring here, so you can play with that spring and make this come in at an earlier, at a little bit less throttle, a little bit later throttle, however you want your shift feel to be. And everything I'm telling you here, this is something that would be a lot of hours developing. And it would really only work for a particular vehicle. So if you have a car you really want to dial it in, again, these are when you would vary these things. Say, for example, if I were to do an R&D program, like a lot of these companies do that make valve body kits and things, I decide, okay, I'm going to rework this for a particular vehicle. We could spend hundreds of man hours redesigning all these circuits and make this car shift exactly the way we want it to shift, and then sell it as a kit. All right, here's what we did, here's what worked, here you go. Well, your thoughts on how this should shift might be different than mine, or my team, whatever. And you might not like it. Maybe it wouldn't really work that great on your car. So again, this is all stuff, we buy into this stuff when we buy these shift kits. Somebody decides, yeah, we don't like the shift feel, it's too intense at half throttle, or too intense at pot throttle, wide open throttle, not intense enough, whatever. It's all subject to opinion. And somebody sits and redesigns all this from what Ford has done, and maybe the masses will like it better, maybe they won't. But this is all essentially what we're buying into when we buy these types of kits. And maybe you'll like it, maybe you won't. Maybe you'll actually like what the factory did better. In some cases, I like what the factory did better than when some of these kits I was using. In the beginning, when I didn't really know anything, I would use these kits because I thought, well, I want to do a good job for the customer. I want it to last. I want it to have a better shift feel and all the wonderful things that they advertised on the box. And so I'm going to spend the money and I'm going to do this and I'm going to have a better product for my customer. Well, as the years went on and I started to understand some of this stuff, what I've found out for me is that sometimes I liked what the company did, sometimes I didn't. And it depends on what transmission, what valve body kit we're talking about here. I don't want to give you a list of what I like and what I don't like, because I'm not trying to badmouth anybody. It's just maybe my goals or my taste is different, You guys might really enjoy chocolate ice cream, but I like the vanilla flavor, Whatever it is, we're just all different, So it's not a good or bad or a rip-off or anything like that. I'm not trying to apply that. It's just different. So if you understand this a little bit, maybe if you were so inclined, really love the vehicle and were really a fussy individual, these are things you can tailor, Or maybe you could block this valve one way or the other, so it no longer has this function. Maybe you don't like the function. Maybe you don't feel like you need it. You can also drill the holes to whatever size you want yourself in the separator plate. Again, all things you can experiment with. This is your governor assembly. This is basically a pressure regulator and tells the shift valves when to shift based on the speed of the drive shaft. That's something that can be played with as well. That could be a long video right there. Just talking about that governor and how to work that. Alright, half hour in. Guys, I want to go. So I'm going to hurry up here. You probably want to go too. 3-4 accumulator. I'm sorry, 2-3 accumulator. This is basically softens the 2-3 shift. Some people just block this out altogether. Some people leave it alone. Some people critique it. How do you critique it? Right here. This little valve here is essentially another pressure regulator. So what this does, if you'll follow this, it's on the small end of the valve. Your clutch pack is on the big end of the valve. There's also a spring here as well. And this here, this valve basically relieves this pressure. So you can experiment with this spring here to change that feel. You could potentially also, it doesn't show it to you, but there's a spring here. You could play with that spring. So that's all fun stuff that you can spend hours doing. Anybody have more interesting life than me? Probably so. Alright, here's a valve, 3-4 shift valve, we kind of went over that. TV limit valve, here's something fun for the whole family here. So this basically will limit the amount of TV pressure you can produce. So say for example you want more TV. And what's more TV going to do for you? It's going to increase the shift points at wide open throttle. Also increase the maximum amount of line pressure the unit will see. So if you want to increase TV pressure, you can play with this spring. And maybe you want to decrease maximum TV pressure. You don't want maximum pressure to be as high. You don't want wide open throttle shift points to be quite as high. You could reduce that spring. Another thing that's in play in that circuit, let me see if I can find it. Yeah, right here. Sorry. TV relief valve. Hope you can see that. TV relief valve. So in case you were to just, say, block that valve or it's stuck or whatever, this is kind of a secondary relief valve. Reason they do this is so you don't overpressurize the unit. Because if you just went and blocked this valve from working, you could potentially overpressure the unit. And so that's something you got to be careful with. But they have this extra relief valve, so that won't happen. So that's a good thing, but maybe you want to roll the dice, maybe you want to do something more radical, and you want to block this off completely, and then make this, you could potentially make this adjustable. And you could do it through a window through the side of the oil pan if you really wanted to get creative. And you could actually adjust your wide open throttle shift points and your max line pressure. Just giving you some ideas here for you guys that like to experiment with things. All right, 1-2 shift valve, that's pretty self-explanatory. Shifts you into second. This does not have that regulator valve on it like the others. So if you really wanted to play with that shift point, the only thing you can do is there's a spring here. you could mess with that spring, or here's the really fun part, when you have to change the diameter of the valve, either at the top portion here or maybe at the bottom. That's fun. Machine work into the case, into the valve body casting, making new valves. That's a lot of fun. I can tell you that. All right. And yes, I'm being sarcastic if you weren't sure. Overdrive servo regulator valve. So basically what this does, on your overdrive servo, there are times where you want to regulate the apply oil on it to soften the shift. Times where maybe you don't. This is a 3/4 shuttle valve. This kind of turns this regulation on and off is essentially what it does. Things you could maybe play with there. I'm going a little faster because this video is getting long and I want to go. And I don't know how to splice video, but so 1-2 capacity modulator valve. This here works with this 1-2 accumulator valve, and what these things do, they work together to soften the 1-2 shift. Okay. Most of your valve body kits will mess with this stuff to give you a firmer 1-2 shift. Lots of things you can do here. Lots of options on how to play with this. If you want to just eliminate it altogether and just have a nice firm, all in its glory 1-2 shift, you can just block this valve. There's a little spring down here. Just block it so it doesn't move. Takes this out of the equation. You can play with blocking this, changing springs. You can partially block it. There's so many options here that you can do to make that 1-2 shift softer or firmer or whatever you want to do. So let's see. I didn't go over this one. I skipped over this one. This orifice control valve. This kind of confused me at first for quite a long time. This is also in the same pocket with that valve I was showing you for the 2-3 accumulator. This valve here, basically what it does is, it's kind of a safety, if you will, where it won't allow the unit to make a shift from second directly to fourth. It makes sure that the unit can go from 2, 3 into 4, instead of going 2 to 4. And the reason for that is it can damage the overdrive band if it were to try to do that, or just create just a very undesirable shift feel. So that's the purpose of that valve. And, I don't know, if that's something you really want to mess with too much. You could block it so it'll just allow the unit to shift when it wants to shift and go where it wants to go, but I don't know, I don't really see a lot of reason to play games with that. But maybe if you have you have one of these pesky units that won't shift into fourth, this could be an area of investigation as to maybe this is why this is not properly functioning, or functioning in a very inopportune time, maybe. So, there's a spring up here. Maybe the spring has broken. Maybe somebody has replaced the spring with not a correct spring. Maybe the spring has fatigued over time. A lot of reasons. Maybe this valve is hanging up. A lot of reasons that maybe it won't allow you to shift into fourth at all, ever. Because I hear that a lot. Hey, the unit just fresh rebuild, whatever. Maybe it's not a fresh rebuild, but unit just will not shift into fourth gear. Well, this is something to look into. Not easy to pinpoint, but something to look at. All right, so I think I've kind of covered all these valves. I know I kind of went over it quickly. I could probably do a video on each valve, honestly, and some of these valves, quite honestly, I understand more than others. Some I experiment with, some I do not. You know, I don't know. Just a lot going on here, and we could get into all the orifices and the separator plate, and you know, this would literally be a course, you know, to really fully grasp this valve body. But if you're somewhat familiar with it, or maybe you are somewhat curious about it, maybe this kind of helped you a little bit, you know. Maybe it didn't, but there is also mentioned quickly, there's a 3/4 accumulator valve that they eliminated in like 89 or something. They stopped doing this. They took it out of the circuit. This was just another avenue to soften the 3/4 shift. I don't know why they took it out. Probably to save a few cents, honestly. You know, I'm not opposed to having them in the circuit, but it's not necessary. And when I sell a valve body to somebody, just an FYI, you don't have to have this in the case, because I never know if you do or not. So I automatically just chop this circuit off within the valve body, so you don't have to worry about it. All right, guys, if you like this kind of stuff here, me rambling in front of a page of squiggly lines, great. Let me know in the comments. Please try to refrain from emailing me, hey, what's wrong with my AOD? I have no idea. I'd have to see it, you know, especially in AOD. Those can get pretty complex, you know, but in any case, it's not that I don't want to help you. It's just that, you know, I got a lot of stuff I got to do in life, and I can't. I get so many inquiries, but I have to kind of stick to the paying customers, unfortunately, for you that just want help. But that's why I do these videos. So if there's something you need help with, I will try my best to do a video on it. Of course, it's not going to happen overnight, so you have to be understanding of me there. So it's just, all right. I appreciate it, guys. I am off.